Good afternoon, all of you. So, this particular class, I will discuss two different subject syllabus. One is the EC 501, another is the EC 503. Today, both the classes will be taken by me, and this is the initial class. So, for this reason, I will combine the two classes, and I will discuss the content of the syllabus. Next day onwards, we will start the subject, but before that, we have to see the content of the syllabus according to the university norms, and what are the different books, what are the different process that we will follow to successfully complete the course. Before that, what I will do, I have to share the screen, and then we will start our discussion. Just 1 minute. So, if you see, this is the official syllabus. First, we will discuss about the EC 501, then we will discuss about the EC 503. So, if you see, this is the official syllabus of the EC 501, and in this syllabus, obviously, this is a electromagnetic waves. So, 3 credit subject is there. And this 3 credit subject, we are finding out the content of the syllabus. Content of the syllabus means what will be the different modules that are prescribed by the university. So the module 1, there are 4 different classifications: module 1, module 2, module 3, module 4, and the module 5. So you will see separate 5 modules that there. Today's class, we will see what are the internal part of this particular module. So we will start with the module 1. In module 1, that is electromagnetic waves, semester 5, we are studying in the semester 5, that is EC departmental course. So module 1, we will find the basics of vectors. So initially we have to start with the basics of vectors, vector calculus, Maxwell's equations, because Maxwell equation is the fundamental one to study the electromagnetic theory, basic laws of electromagnetic, Poynting vector, boundary conditions at media interface. So these are the different topics that are coming under the module 1. So in case of module 1, if you follow the syllabus, you will find the basics of vectors are there: vector calculus, Maxwell's equations, basic laws of electromagnetic, Poynting vector, boundary conditions, and media interface. So many different modules are maintaining. In case of module 2, if you go to the next one, if you go to the module 2, we will find we are discussing about the uniform plane wave propagation of wave polarization, the Poincare sphere. So that's the fundamental Poynting theorem, basic study, the Poincare sphere, wave propagation in conducting medium. So module 2, you will see different types of classification for the uniform plane wave, propagation, how the wave is propagating from one medium to another medium, wave polarization, Poincare sphere, wave propagation in conducting medium, phase and group velocity, so surface current, and power loss in a conductor. So many different topics are including. Next, if you see, that is the plane waves at a media interface. So plane waves at a media interface, plane wave in arbitrary direction, reflection and refraction at and dielectric interface, total internal reflection, wave polarization at media interface, deflection from a conducting boundary. So different topics will come under the module 2. So the uniform plane wave, that is the thing. Just 1 minute. Uniform plane wave, that is the thing that we will study under this article. But for the next part, what we will do, we will study this thing, that is the plane waves at a medium surface, plane wave in arbitrary direction, reflection and the refraction at dielectric interface, total internal reflection, wave polarization at media interface, deflection from a conducting boundary. So different several topics we'll mention here. Next, we'll go for the module 3. Module 3 is a very interesting one, and so-called, I'll say that is a slightly interesting, easiest one. So in case of module 3, we have to study. So that is the easy. I have mentioned that I'm easiest one, but that is not the thing that you have not to study. That is also very interesting one. So that is a module 3 will find transmission lines, equations of voltage and current on transmission line. Sorry, propagation constant and characteristic impedance and reflection coefficient and VSWR, impedance transformation on lossless and low loss transmission line, power transfer on transmission line, Smith chart, admittance Smith chart, applications of transmission lines, impedance matching, use transmission line sections as circuit elements. So different topics will come under this particular sections. Module 3, if you see the section. So transmission lines, equations of voltage and current on transmission line, propagation constant and characteristic impedance and reflection coefficient and VSWR, transformation on lossless and the low loss transmission line, power transfer on transmission line, Smith chart, admittance Smith chart, application of transmission equations, impedance matching, use transmission line sections as circuit elements. So different topics will come under this section. For the module 4, is basically the wave propagation in parallel wave, plane waveguide, analysis of waveguide, several general approach we have to study. Rectangular waveguide, so many different types of waveguides are there. So rectangular waveguide, modal propagation in rectangular waveguide, surface currents on the waveguide walls, field visualization, attenuation in waveguide. So these are the different topics that will come under this section. So if you see the module 4, you will find wave propagation in parallel plane waveguide is there. Analysis of waveguide, general approach will be there. Rectangular waveguide, modal propagation in rectangular waveguide, surface currents on the waveguide walls, field visualization, attenuation in waveguide. So many different topics that we have to. That is basically dedicated for the waveguide section that we have to study. Next, module 5. That is the radiation pattern. You will see the different types. So that is the antenna section basically. So in this section, what you have to study, you have to see the different types of radiation patterns. So module 5, the radiation, that is a solution for potential function, radiation from the Hertz dipole, power radiated by Hertz dipole, radiation parameters of the antenna, receiving antenna, monopole and the dipole antenna. So different types of antenna. Already I have mentioned the term, that is this is the antenna section. So module 5, if you see, that is the different radiation pattern we have to study. So the solution for potential function, radiation from the Hertz dipole, power radiated by Hertz dipole, radiation parameters of the antenna, receiving antenna, monopole and the dipole antenna. So these are the different topics that we have to study. So this is the section, that is the electromagnetic waves. So this is the EC 501. Under this section, what are the different topics we're finding out? So we'll see, broadly see the 5 modules. Again, I am repeating the thing. That is a 3-credit paper. So module 1 is basically basics of vectors, vector calculus, Maxwell's equation, basic laws of electromagnetic, pointing vector, boundary conditions, and media interface. So many topics are there. For the module 2, we will find uniform plane wave propagation of wave polarization, point case, surface current and power loss in a conductor. So many different topics we are finding out. In the plane waves at a media interface, plane wave in arbitrary direction, total internal reflection, wave polarization at media interface, reflection from a conducting boundary. So many topics that will come under this section. So this module 2, if we see carefully, module 2 is the uniform plane wave radiation, propagation of the wave polarization, Poincare sphere, wave propagation in conducting medium, phase and group velocity, surface current and the power loss in a conductor, plane waves at a different media interface, plane wave and arbitrary direction, reflection and the reflection in direct media interface, total internal reflection, wave polarization at media interface, reflection from a conducting boundary. So many different topics we'll see here. Module 3, that is the third module according to our syllabus. So that is we discuss about the transmission line. I have already mentioned that is a slightly easier section. So module 3 will be the transmission line one. So that is the transmission line equations of voltage and current on transmission line, propagation constant and characteristic impedance. Some directions are there, and reflection coefficient and VSWR, impedance transformation on lossless and low loss transmission line, power transfer on transmission line, Smith chart, admittance Smith chart, applications of transfer lines, impedance media matching, use transmission line sections as circuit elements. So many different topics you will find out of this section. Module 4 is the wave propagation in parallel plane waveguide, analysis of waveguide general approach, rectangular waveguide, modal propagation in rectangular waveguide, surface currents of the waveguide walls, field visualization, attenuation in waveguide. So many different topics we are finding out. So that is the section under that will come under the module 4. So wave propagation in parallel plane waveguide, analysis of waveguide, general approach, rectangular waveguide, modal propagation in rectangular waveguide, surface currents on the waveguide walls, field visualization, attenuation in waveguide, and the last module, that is the module 5. Module 5 will come under this radiation solution for potential function, radiation from the Hertz dipole, power radiated by the Hertz dipole, radiation parameters of antenna, receiving antenna, monopole antenna, and dipole antenna. This is a dedicated antenna section we are finding out. So if you see the last module, that is the module we are getting, that is the radiation solution for potential function, radiation from the Hertz dipole, power radiated by Hertz dipole, radiation parameters of antenna, receiving antenna, monopole, and the dipole antenna. So many topics we are getting here. So this is the subject electromagnetic waves, subject code is CC501. For this book, they have mentioned the RK shift down curve electromagnetic waves books. Jordan Ballman book is also good one. Rao, David Cheng, many books are there, many good books are there in electromagnetic theory. So next class onwards, we'll see the Jordan Ballman as well as the Shadiki is there. Shadiki is also a very good book, and I'll share one note material. I've made one note. This note, so this note you can use as a reference. All the points, all the things, all the topics are mentioned in the note. You can study the note well, and you can score good marks. Next, I want to emphasize on the another topic, that is the EC503. That is the digital communication and the stochastic process. That is a introductory class, introduction to the process. If you see that is the SPs means that is a process you have to see. So that is the subject name is digital communication, the stochastic process. That is a lengthy subject. If you see the 3 lecture plus 1 tutorial, though this is a 3.5 credit subject. So this definition of the examples of the SPs, classification of the random process according to the state space and the parameter space, elementary problems, the stationary and the ergodic process, correlation coefficient. So if you see all the things, all the points that just now I have mentioned, these are the part of this stochastic process. So definition and examples of the SPs, classification of the random processes according to the state space and the parameter space, elementary problems, stationary and the ergodic process, correlation coefficient, covariance, autocorrelation function and its properties, random binary wave, power spectral density. These are the different topics that will come under this section. Definitions of the examples of the Markov chain, this transition probability matrix, Chapman, this Kolmogov equations, calculations of the end-step transition probabilities. So different topic, different sections will come under this thing. So EC503, this is a digital communication stochastic process, very fundamental, very important subject for the electronics and communication engineers. So in this case, what you will see, we'll see that is a 3.5 credit subject, and we'll find out module 1, 2, 3 as well as 4 different modules are there, though module 4 is the lengthiest one. So module 1, you see that is a definition, that is the introduction to the stochastic process, SP's function. So definition and examples of SP's, classification of the random process according to the state space and the parameter space, elementary problems, stationary and the ergodic processes, correlation coefficient, covariance, autocorrelation function and its properties, random binary wave, power spectral density. Definition and examples of Markov chains, transition probability matrix, so Chapman Kolmogov equations, calculation of in-step transition probability. Signal vector representation, that is a very fundamental thing. If you want to analyze any kind of signal, so you have to see the signal vector representation. So analogy between the signal and the vector, distinguishability of the signal, orthogonality and the orthonormality, basis function. These are basically mathematical portion, but you have to study in detail in this case. So signal vector representation, analogy between the signal and the vector, distinguishability of the signals, orthogonality and the orthonormality, basis functions, orthogonal signal space, message point, signal constellation, geometric interpretation of the signals, likelihood functions, Schwarz inequality, Gram-Schmidt orthogonalization procedure, very, very important one. This Gram-Schmidt orthogonalization procedure, response of the noisy signal and the receiver, maximum likelihood decision rule, decision boundary, optimum correlation receiver, probability of error function, complementary error function, type 1, type 2 error. So many different types of signal vector representation formats, signal vector representation thing we have to discuss. So signal vector representation, that is the analogy between the signal and the vector, distinguishability of the signal, orthogonality and the orthonormality basis function. orthogonal signal space, message point, signal constellation, geometric interpretation of the signals, likelihood functions, Schwarzschild inequality, Gram-Schmidt orthogonalization procedure, this response of the noisy signal at the receiver, maximum likelihood decision rule, decision boundary, optimum correlation receiver, probability of the error function, complementary error function, type 1, type 2 error. So many different topics we have to discuss under this article. Next, we have to go to the module 3, that is the digital data transmission, because ultimately you have to transmit the digital data. So concept of sampling, the first digital modulation PCM we have to introduce in this particular section. Before that, concept of sampling, the pulse amplitude modulation, PAM, interlacing and the multiplexing of the samples, pulse code modulation, PCM, quantization, uniform and non-uniform quantization, quantization, noise, binary encoding, A law, mu law. These are the different laws that will come under this section. Differential PCM, delta modulation and the adaptive delta modulation. So many different topics will come under this particular section, digital data transmission. So concept of sampling, pulse amplitude modulation, PAM, interlacing and the multiplexing of the samples, pulse code modulation, PCM, quantization, uniform and non-uniform quantization, noise, binary encoding, A law and mu law compounding, differential PCM, delta modulation, adaptive delta modulation. Next section, that is the digital transmission components, source, multiplexer, line coder, degenerative repeater, concept of line coding, polar, unipolar, bipolar, NRZ, RZ, Manchester differential encoding, and their various PhDs, pulse shaping, intersymbol interference, ISI, I pattern, Nyquist criteria for zero ISI, equalizer, zero forcing equalizer, timing instruction. So digital transmission components, source, multiplexer, line coder, degenerative repeater, concept of line coding, polar, unipolar, bipolar, NRZ, RZ, Manchester differential encoding, and their PhDs that we will see. Pulse shaping, different types of intersymbol interference, very important article. I pattern, Nyquist criteria for zero ISI, equalizer, zero forcing equalizer, timing expressions that we have to study. Next, the module 4, that is the last module and the biggest one. So this is the different types of digital modulation technique, coherent and non-coherent binary modulation techniques, basic digital carrier modulation techniques, ASK, FSK, PSK, that you have to complete. So digital modulation technique, if you classify types of digital modulation, coherent and non-coherent binary modulation techniques, basic digital carrier modulation techniques, ASK, FSK, PSK, coherent binary phase shifting, BPSK, so geometrical representation of the BPSK signal, error probability of BPSK, generation of detection of BPSK signal, power spectrum of BPSK. So different parameters you have to complete here regarding the modulation techniques. So coherent binary phase shifting, BPSK, geometrical representation of the BPSK signal, error probability of the BPSK, generation and detection of the BPSK signal, power spectrum of BPSK, concept of M-array communication. M-array communication, phase shifting, the average probability of the symbol error for coherent M-array PSK, power spectrum of MPSK, different types of techniques that will be included here. Next, we will see another part of the PSK, that is called the quadrature phase shifting, QPSK, error probability of the QPSK signal, generation and the detection of the QPSK signal, power spectrum of QPSK signal, offset quadrature phase shifting, this OQPSK that we will include here. Coherent frequency frequency shifting, FSK, binary FSK, error probability of BFSK, signal generation detection, coherent binary FSK signal, different types of FSK mechanisms, power spectrum of the BFSK signal, minimum shifting, MSK, signal constellation of the MSK waveforms, error probability of the MSK signals, Gaussian minimum shifting, that is called the GMSK, basic concept of the wave DM constellation diagram that we have to study. So coherent frequency shifting, FSK, binary FSK, error probability of the BFSK signals, generation and the detection of the coherent binary FSK signals, power spectra of BFSK signal, minimum shifting MSK, this signal constellation of the MSK waveforms, error probability of the MSK signal, Gaussian minimum shifting, GMSK, basic concept of OFDM, orthogonal frequency division multiplex, very important topic, constellation diagram we have to study. Some performance issues for differential digital modulation techniques that you have to see. So error vector magnitude, EVM, the I pattern and the relative constellation error, RC, conceptual idea for the vector signal analysis, VSA. So sorry, these are the additional topic that you have to complete. So some performance issues for the different digital modulation techniques will be there. Error vector magnitude, EVM, I pattern and the relative constellation error, RC, conceptual idea for vector signal analyzer, VSA. So these are the different topics that will come under this article. And many good books are there for the digital communication. Hekin is a very good, Tafsheling is also very good. So again, I will combine the thing. I will give some notes as well as I will combine this material with your textbook. So textbook will be one reference, and I will circulate with you some good quality note. So we'll combine the thing and we'll try to complete the syllabus. Due to some technical issues, you are not present in the class. I am expecting that next week onwards will be present in the classroom because these are very important subject. You cannot skip the classes. So try to attend the classes regularly. Thank you very much for your attention. Next, meet in the next class. Thank you.